Python is crucial and important for any aspiring and data analyst. Learning to visualize Python or learning to visualize your data with matplotlibs and getting acquainted with data structures such as pandas, data frame, and dictionary is pretty important for any data analyst and aspiring data analyst. So welcome back to the channel and welcome to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 8. We started learning over the past couple of days, few days ago. I actually took a break on day 7. I actually faced a little bit of challenges with a while I was learning matplotlibs. Good news, I have actually sorted out and found a solution to that challenge, and I'll be sharing it with you today. So on the last live stream, which is day 7, where we looked at the matplotlibs for data visualization, we actually learned a lot how to plot charts, how to plot various variables, with the matplotlib or package in Python. We completed learning all about matplotlibs on day 7. You can catch that on the live stream tab on the channel. So if you want to start with me from the beginning, I encourage you to start from day 1 so you can quickly catch up before we start moving at a pretty good and lovely pace. And so today we're looking at panda dictionaries and pandas in Python, which is an alternative to Python list. So we've covered list in Python probably on day 3 or day 4. You can catch those live stream, the list in Python, understanding what lists are on the live stream part of the channel. So we are looking at dictionaries and pandas in today's live stream, which is a standard to work with tabular data in Python. So you get hands-on experience with creating and manipulating data sets and learn how to access the information you need from your data structures in dictionaries and pandas. That will be covering in today. So the live stream is actually will be for an hour, but this Python is a pretty highly technical skill to learn. So we won't be rushing it. Each chapter, we are in the course called Intermediate Python in Python. So this particular course contains 5 chapters. So the first chapter is matplotlib, which we've covered on day 7 and probably day 6 and day 7. We spent 2 days on it. So this dictionary is pretty wide. Also, dictionaries and pandas in Python, we'll definitely be spending 2 or 3 days on it just to make sure we cover it at a good pace and we're not rushing it. We're actually understanding what we are learning with a lot of practice also. So welcome back to the channel. Also, all data sets are CSV files or Python files that we'll be using and we continue to be using. I will link it under the YouTube description in the link. So do make sure to download those files and practice along with me. So without further ado, let's get back to learning and welcome to day 8 of our Python learning journey. So I'll just go to my DataCamp or dashboard real quick. I'm actually subscribed to on DataCamp on a 1 year subscription. So that's why I'm able to learn at my own pace and follow the course on DataCamp, which is pretty cool and well organized, especially for practice and owning the skills you've covered. So what we are going to do now is I'll just quickly show you what the career track section looks like. So we've covered associative data analysis in SQL. We've covered in Python also. Just a minute there. So we've covered in Power BI also. We are now moving to Python, which is one of the core tools I plan to upskill myself with this year. So we've actually been upskilling ourselves. It all started from data analysis in SQL. Then we completed that for a period of 100 days. Then we did Power BI also for 69 days. We were able to finish and complete the Power BI career track in 69 days. And I plan to, I'm working on some project behind the scene, which I'll probably be making in a video and share with you so you can see the type of project I actually built in SQL and Power BI also. So by the way, I just decided to start learning my Python at least 1 hour every day, taking 1 hour out of my time to upskill myself also. So if I click on data analysis in Python, as you can see, we are just 13%. We actually started from 0% and we're actually moving at a good pace. So we are on intermediate Python. So we've covered the maths plot lib. So we are moving to dictionaries and pandas today. So I'll just click on continue real quick. But before we continue, let me show you the challenge we're facing on the matplotlib section. So if you're following along from the math plot lib section, we actually imported our packages. Then we pointed to our data sets. You can have access to these data sets following the link under the YouTube description. So to download the data sets. So after that, we know we did some manipulation just to view what the data set looks like. Then we actually pick a couple of columns to analyze the data sets. So that was the challenge that we faced here. So we picked this GDP capital column, which is this last column here, and this life expectancy. So but before that, I actually converted this column of data to an array. So you could just do that by pointing to the name of the data, then equating it to np.array. That's because we've imported the numpy package to be able to do that. You get it now? So you could just watch all of this on day 7. You understand all that is happening here. So the end goal is that when after converting it to an array, we only pick a couple of columns. We pick the life expectancy column, which is this column here. As you could see here, I use this index or a notation to bring out the column from the O array. So I also pick the GDP per capita column, which is -1, which is the last column here, -1. So there was a way we did that. We're actually using indexes here and variable and index to call on certain columns in a bunch of columns on a data set. Do you get it now? So after that, we start doing our variables. We also called on the population. I'll come back to this population or column later. So we're actually using one, two, three columns for this data visualization in math.lib. So after that, we went down and did a couple of coding. So we could just catch up on that on the live stream. So the challenge was where we were actually visualizing our data sets. That was when we ran into a couple of challenges because see the data sets. In this case, we were plotting. This is a plot. This is a line plot, but you can see the visual doesn't actually make sense. Then we converted it from a line plot to a scatter plot. You can see when we're using a line plot to visualize the GDP per capita column and the life expectancy, the results wasn't making sense. That means those variables is not proper for a line chart. Then we went over to actually make use of a scatter plot, and the result started making more sense. They also built a scatter plot on population and life expectancy, and we see the correlation is not correlated at all. If you understand what correlation is, you can see the variables are dispersed there, while they are all packed here. You can see there's no correlation between population and life expectancy, but there's a correlation between GDP per capita and the life expectancy. As the GDP per capita is growing, the life expectancy is also increasing. You can see that. So the challenge was now when we wanted to add a third variable, which is population here, which is this population here, just to make sure that we distinguish between the variables, the bubble sizes. So we actually ran into an error because if you watch day 7, you could see that my population the data type was different. Let me go back a little bit up here. So say that my life expectancy is a float data type. My GDP per capita here is a float data type, while my population is an integer. So we ran into that error on day 7. That was why we were getting the error. So what I did was to convert the population data type to a float also. So that was what we did. That was the solution. So if you are facing the challenge on day 7, this is the solution. All you need to do is convert the population. And see the population data type, which is from here. You convert it to a float data type by just writing a variable float. I just definitely write float pop equals to np.array pop data type equals to float. So it's going to convert it from an integer like this, you could see, to a float data type like this, which is same data type as the other two variables that we're using in our to make the bubble size different, to differentiate between the bubble size here. As you can see here, you can see. So I had to use it. Also, what I did was I scaled it. Interesting. So I had to scale it when I actually use the flow data type that I converted here. When I converted it straight to a flow data type, let me just copy this real quick. Let me copy this variable here and actually use it here so you can see what I actually mean. Where is that? Okay, this is the bubble size. It's not here. This place here. If I use it straightforward without converting it, you see what will happen here? If I run the code, pay attention to what happens now. You can see the sizes of my bubbles are too large. They are not scaled to differentiate between each population from the GDP per capita and the life expectancy variable. So we needed to convert it. So we convert it to a square. We use square root notation here to convert it. So just copy this code right here. So I scale the population so that it will differentiate to have the exact value for each population in the GDP per capita and the life expectancy, especially for the country. You could see, let me scroll back up really quick. The population, they are different for for each country. So if I didn't scale it, I won't actually get the correct visual. So we have to scale it right here using this scale and converting it. So I'm going to make use of this scale population variable right now, and my chart is going to make sense. My visual rather. You can see now. So it's now differentiating very well between each population size. So that was the challenge we faced on day 7. I had to just take my time to find a solution to it. Then this one, I still need to come back. I don't know how to create dictionary yet. So we wanted to differentiate the color sizes for each different. You can see, or they are all blue. So the next challenge was to differentiate it with colors. So using dictionary, and we're going to be learning all about dictionary today. So that was the challenge on day 7. I hope that explains it if you are actually following along and you face same challenge I faced on day 7. So you can just pause my explanation and try to use the code I've come up with here and try to solve the challenge. So that's it there. So let's move over to lesson and start our dictionaries really quick. Let me just click on it. So we want to start dictionaries today. So I did justice to the explanation on the day 7 of the maths plot lib challenge. So let's learn all about dictionaries on day 8. So the goal is to cover a couple of lessons. You can see the lessons are pretty much. We just break it down to this part: dictionaries, motivation for dictionaries, create hierarchy, create a dictionary, access dictionary. We could try to cover up to this and cover the last parts tomorrow on day 9, hopefully. So let's see. Let's get started. Let me just launch my I want to open my file here. I'll just take it to my second screen. Welcome back.
Welcome back.
Hold up a minute. Let me just change my output device to my headsets.
Welcome back. Now do I have a treat for you. In this video, I'll be talking about a new Python type, the dictionary. Dictionaries are so useful in the data world.
That's two dictionaries.
And to see this, imagine the following. Welcome back. Now do I have a treat for you. In this video, I'll be talking about a new Python type, the dictionary. Dictionaries are so useful in the data world. And to see this, imagine the following. You work for the World Bank and want to keep track of the population in each country. You can put the populations in a list. You start with Afghanistan, 30.55 million. Albania, 2.77 million. Algeria, around 40 million, and so on. To keep track about which population belongs to which country, you can create a second list with the names of the countries in the same order as the populations. Now suppose that you want to get the population of Albania. First, you have to figure out where in the list Albania is so you can use this position to get the correct population. Remember about the method index, a list method you learned about in the Intro to Python course? Let's use it to get the index of Albania in countries like this. Now, we can use this index to subset the pop list to get the population corresponding to Albania. As expected, we get 2.77, the population of Albania in millions. So we built two lists and used the index to connect corresponding elements in both lists. It worked, but it's a pretty terrible approach. It's not convenient and not intuitive. Wouldn't it be easier if we had a way to connect each country directly to its population without using an index? This is where the dictionary comes into play. Let's convert this population data into a dictionary. I included the lists to start from on the top here so you can see what's going on. To create the dictionary, you need curly brackets. Next, inside the curly brackets, you have a bunch of what are called key value pairs. In our case, the keys are the country names and the values are the corresponding populations. The first key is Afghanistan and its corresponding value is 30.55. Notice the colon that separates the key and value here. Let's do the same thing for the two other key value pairs and store the dictionary under the name world. If you now want to find the population for Albania, you simply type world and then the string Albania inside square brackets. In other words, you pass the key in square brackets and you get the corresponding value. The key opens the door to the value. Pretty poetic, isn't it? This approach is not only intuitive, it's also very efficient because Python can make the lookup of these keys very fast, even for huge dictionaries. Get lyrical about dictionaries yourself in the exercises. In the next video, we'll delve deeper into how to use them. I can't wait.
So dictionary are just key pair values. So before we move on, I'll just create a Python, a Jupyter notebook file for this. And just go back to intermediate Python. So I'm going to create a difference. This for matplotlib. So we've covered everything we need to cover. So we just come back to the dictionary part here also. We need to create a dictionary to differentiate each country. So differentiate these different blue marks here. I'll come back to that later. Let's just focus on creating dictionaries here today. I'll just create a new Python file, a new notebook. So I'm going to call it a dictionary. Select. So I'm going to rename it as dictionary. Dictionaries. Dictionaries. Click on OK. Cool. Probably we need to still import some Python packages. Let's see if we need to import that. Let me just refresh this. Let's have name a dictionary. I also copy all these my packages imports. So you definitely will be needing it almost every time you need to work. So we've done that. So it says motivation for dictionaries. So to see why dictionaries are useful, have a look at the two lists defined in the script. Countries contains the names of some European countries. Capitals list the corresponding names of their capital. So use the index method on countries to find the index of Germany. Store this index as in int underscore jar. So that was what we should store it as int underscore jar. Okay. Use int underscore jar to access the capital of Germany from the capitals list. Print it out. So we have defined countries and capitals. So get index of Germany. Okay. So the index of Germany should be. So we're going to store it under the index of Germany. I'm going to use int, create a new variable, index of Germany. So that's what that int means. It's going to be countries dot index. So that's index. So I'm going to open a bracket. So that should be, then I'll call on Germany like that. I'm going to change my mouse to a Germany. So use index to use in the int underscore jar to print out the capital of Germany. So I've just called on int underscore jar Okay, capital. So this is going to be Berlin. Berlin rather. It's going to be Berlin. Rather. So I'm just going in underscore jar. If I print it out, first just say print. So you should print the capital Berlin for me. Let's run the code. Hold up. What is the mistake here? Use to access the capital of Germany from the capitals list. Print it out. Oh, hold up, hold up, hold up, hold up, hold up. Okay. Okay. My mistake there. Now let's run the code again. Good. So it's going to return the index of Berlin. So now it's printing out 2. Okay, let's submit the code first. You see, print capital. So have you used the appropriate? So I use the appropriate capitals underscore in. So I want to print the capital, not the variable. So I'm going to point to the capital. Yeah, capital. Then I'll mention the capital and I'll wrap that in the variable as index capitals. Okay. I'm going to use a square bracket. So instead of returning the index, we're going to return the value for me. Oh, oh, oh. Oh, I didn't spell my capital variable. Now let's do that one more time. You can see barely now. So if you submit the code now, it should make sense, correct? So let's recreate this in Jupyter Notebook. I'm just going to copy all this code and paste it here. So we defined our variables, countries, and capital as countries, Spain, France, Germany, and Norway. The capital as simultaneously. So we get an index of Germany, creating in underscore Germany equals to country.index of Germany. So if I run the code, you can see it's going to print Berlin with the capital of Germany. Pretty straightforward there. Okay, create dictionary. So let's turn it into a dictionary rather than a list. So the countries and capital lists are again available in the script. So it's your job to convert this data to a dictionary where the country names are the keys and the capital are the corresponding values. So it's going to be key pair values. So as a refresher, here is a recipe for creating a dictionary. So my dicts, you're going to use the curly bracket, key 1, key 2, value 2. So in this recipe, both the keys and the values are strings. This will also be the case for this exercise. So both the keys, so if you're using key pair value, they are both string. Okay, yeah, both the keys are string in this case because they are not integer. So with the string in countries and capitals, create a dictionary called Europe. So we have a dictionary called Europe here with 4 key value pairs. Beware of the capitalization. Make sure you use lowercase characters everywhere. Okay, so they've created Spain and Madrid for us. So just to make it easy and super, I'll just copy it real quick there. So it's going to be key pair value. I'll put a colon right there. Not a semicolon. So it's going to be Paris. Same thing here. Germany. The dictionaries are better because we're using a list. I still have to create uh, the variable for that before I can actually access it. Then for Norway, keep a value. Then the capital is Oslo. So now let's print Europe. We call print Europe. Let's see. So you can see we've just created our first dictionary. Interesting. I'll just copy this real quick. So if I run and see key pair value, these are to create a dictionary. So I'm going to define, so if you're using a list, which is much more technical, so countries, capital, I'm going to get the index of that country as I want to create another variable to make it an index for the country. Then I'm actually going to be printing capitals dots, calling on capitals here. Then the index of this thing, kind of pretty tricky there, but this is pretty straightforward and easier. Let's submit the answer there. So great. Now you've built your first dictionary. Let's get serious. And let's see how to make use of them. Oh, interesting. I've been off for a couple of days. So access dictionary. So if the keys of a dictionary are chosen wisely, accessing the values in a dictionary is easy and intuitive. For example, to get the capital for France from the Europe, you can use Europe.France. So it's going to call on, what if I want to get the country, not the capital? Let's see how to do that. What if I prefer to get the country or the capital? Print out keys in Europe. Print out the keys in Europe. You just say print, open, then Europe. That's pretty straightforward. Now print out the value that belongs to the key Norway. So I'm going to say Europe. I'm going to use not square bracket, just normal bracket. Then I want Norway. It's going to be in a single bracket. Norway. Now let's run the code and see. You can see. So these are the keys in Europe. Then the capital for Norway is Oslo here. So print out the value that belongs to the key Norway. Check out which keys are in Europe by calling the keys method on Europe. Oh, the keys method. So let me print that. How do you call the keys method on Europe? Okay, let's see. It's a keys method. Okay, let me run the code again. Oh, you can see the key didn't return anything. Okay, what does the keys method mean? Here, France is the key and Paris. Here, France is the key and Paris is the value it returned. If France is the key, okay. If I run it like this, so print out the value that belongs to the key Norway. So now let's submit and see first. So heroes dot, did you call heroes dot key? So I have to call heroes dot key. What does that mean? Let's see if it's going to return same result, heroes dot key. Now let's see that in action. Ooh, heroes dot keys. Okay, keys is also to be in capital, not key. Okay, now let's see. Print out the keys in Europe, euro dot key. Print out the value that belongs to the key in Norway. So euro dot key, what is it returning for us? So Europe dot keys. I'm only the same code and I'm getting, let's see the AIF. Have you tried using the key method to print out the keys in the dictionary and using the print function to display the value from the key in Norway? Okay. Oh, I have to use print here. But notwithstanding, you don't need to use prints in Jupyter Notebook. If you just write the variable like that, you're going to get your result. Now I'm to print this also. Okay. We are supposed to print this heroes.key also. Print. If we print that, what is it going to return? Let's see. Oh, that's pretty funny. It says print out the value that belongs to key Norway. Okay, the dictionary keys. Okay, the dict key. When I say print Europe.key, you need to print dict keys, Spain, France, Germany, and Norway. Oh, so if I'm printing the keys, I'm actually printing out the countries. Do you get it now? So this allow me to print out the countries. So I said that earlier. So how do I actually print out the countries and not the capitals? So I'm going to use Europe.keys. Then you can if you print it out, you're going to get your result. Now let's see. Oh, correct. So that's kind of interesting. So let me now copy that and try same thing in my Jupyter notebook here. So now instead of want to print out the countries, so we've learned how to access the capital, which is the value of the key. But how do we now print out the key value also? So I'm going to use the variable name dot keys. Then you have to print it out. You can see these keys: Spain, France, Germany, Norway. But in Jupyter Notebook, let me just clean the key parts. Or let me just leave it out. Let me try to copy it here and try it without the print syntax here. If I just say like this, we should still get same results though. Let's run the code. So it prints only the value that belongs to the key Norway. So it skips this print case for Europe. So the best option is to use this in this case then and actually gets your correct results. So that's interesting to see. So that is pretty simple to create keys in Python. Pretty straightforward. So to create dictionaries rather in Python. So we're not getting to the add part though. That's the most important thing. We're not getting to the add part of it. So let's continue and see if we can cover the part 2 today. That is dictionary manipulation. So let's see how to manipulate the dictionary we've created and actually stop here for today. If you say we should continue to Pandas, it may get cumbersome. Too much information in a day is not pretty good. So let's talk about manipulating the in this second part.
In the previous video, we created the dictionary world, which basically is a set of key value pairs. You could easily access the population of Albania by passing the key in square brackets, like this. For this lookup to work properly, the keys in a dictionary should be unique. If you try to add another key value pair to world with the same key, Albania, for example, you'll see that the resulting world dictionary still contains 3 pairs. The last pair that you specified in the curly brackets was kept in the resulting dictionary. Also, these unique keys in a dictionary should be so-called immutable objects. Basically, the content of immutable objects cannot be changed after they're created. Strings, booleans, integers, and floats are immutable objects. But the list, for example, is mutable because you can change its content after it's created. That's why this dictionary, that has all immutable objects as keys, is perfectly valid. This one, however, that uses a list as a key, is not valid, so we get an error. So now that you have an idea of how to build a valid dictionary and how to access it using square brackets, let's see how we can add more data to a dictionary that already exists. Say, for example, that you, an employee of the World Bank, decide to acknowledge the Principality of Sealand. Sealand is an unrecognized micronation on an offshore platform located in the North Sea. At the moment, it has 27 inhabitants. To add this information, simply write the key Sealand in square brackets and assign 27 expressed in millions to it with the equals sign. If you check out world again, indeed, Sealand is in there. To check this with code, you can also write Sealand in world, which gives you true if the key Sealand is in there. With the same syntax, you can also change values, for example, to update the population of Sealand to 28. Because each key in a dictionary is unique, Python knows that you're not trying to create a new pair, but want to update the pair that's already there. You can see this from the printout here. Suppose now that your boss didn't see the humor of adding Sealand to the list and asks you to remove it again. You can do this with del, again pointing to Sealand inside square brackets. If you print world again, Sealand is no longer in there. Good riddance. If you remember the discussion of lists from the intro course, you'll notice that using lists and dictionaries is pretty similar. You can select, update, and remove elements with square brackets. There are some big differences though. The list is a sequence of values that are indexed by a range of numbers. The dictionary, on the other hand, is indexed by unique keys that can be any immutable type. When to use which one, I hear you ask? Well, if you have a collection of values where the order matters and you want to easily select entire subsets of data, you'll probably want to go with a list. If, on the other hand, you need some sort of lookup table where looking for data should be fast and where you can specify unique keys, a dictionary is the preferred option. Now, off to some more exercises on dictionaries. I'll see you back here soon.
Okay, so let's see how we can practice and manipulate our dictionaries in Python. So dictionary manipulation 1. So if you know how to access a dictionary, you can also assign a new value to it. To add a new key value pair to Europe, you can use something like this. Europe, Iceland equals to Reykjavik. Oh, that's German. So this is we want to have a new country. You want to add the capital to it. So add the key Italy with the value Rome to Europe. So I'm going to say Europe, add Italy to Europe. So Europe, we open a square bracket, then we add the key Italy, Italy. So we're going to point to the capital of Italy should be Rome. Yeah, Rome. Print out Italy in Europe. Print out Italy in Europe. So to print out Italy in Europe, we are going to use, so I'm going to say Europe, then curly brackets. I want to print out Italy, which Italy is the country, not the, so I'm printing out the country here, not the capital. So I'm probably going to use keys there. Let me see my Jupyter notebook real quick. If I list these keys, I'm going to only be getting the keys in my dictionary. What if I now say Europe.keys, then Italy? Would that make sense? Let me try it here. Let me delete this. Europe.keys. Uh, let's see first if it is going to work. So it won't work. Okay. What if I use arrow.keys? If I use the index, will the index going to work here? Let me put index of 0 here. Index of 0. I think indexing is going to work here also. Oh, indexing is not working. So how do I print out only the country, one country, without printing out all the keys in the country? Because if I use Europe dot index, so if I use index, okay, let's do like this. Euro index 0. Ooh. Indexing is not working in dictionary. Okay, let's see. I'm curious. I just want to print out the country. Okay, let's continue from here though. So print out Italy in Europe. I should print out Italy in Europe. Okay, to add key. So add the key Italy with the values Rome to Europe. So aside that Italy is not a key in Europe, print out Italy in Europe. Can you see that? So we have the same challenge here. Okay, let's see. How do we do that? I'll just say Europe, and I'm going to mention, oh, it's going to be, oh, okay, I figure it out now. So it's going to be Europe, Italy in Europe. It's going to be Italy, Italy in Europe, in Europe. So let me do it here, my dictionary. So it's going to be, okay, let me do Spain, Spain in Europe. Let's see. Ooh, what do I now say? Print. So I'm getting the same error. My spin has to be in, oh, sorry, in quotes. That was the error there. True, you can see it's done it true, so it is true. What if I remove the curly brackets here? True. That means I've added it. So that has to confirm if you've added a key pair value to your dictionary. Oh, so it's going to be Italy in Europe. So add Poland. I'm going to do Poland also. I just say Europe, open brackets. So add another key value pair, Europe to Poland. Poland is the key, Warsaw is the corresponding value. Poland equals to Warsaw, that's the capital of. So print out Europe now. Let's print Europe. Let's print out Europe and see our results. Oh, interesting. So the first one says add Italy to Europe. We've added Italy to Europe. Print out Italy in Europe. Let's see the results. Uh, so I have to print. Look, let me print it. If I don't print it, it's not going to show in this case here on the DataCamp environment. So I have to use the keyword print in this case. I see print out Europe, Italy in Europe, and see the result is true. And print out Europe. So it is printing out Europe now. So I'm just going to copy this same code here and make use of it in my Jupyter notebook here. So let's see the result we are going to have here. And see Italy in Europe to print out Europe. So we have Italy and Rome. Then we have Poland and Warsaw added already. So our list is making sense. Correct. Well done. Europe is going by the minute. Did you notice that the order of the printouts is not the same as the order? Let me just quickly plug in my laptop there. Okay, we are back and charging. So it says, did you notice that the order of the printout is not the same as the order in the dictionary's definition? That's because dictionaries are inherently unordered. Inherently unordered. So Spain, Madrid, France, Paris, Germany, Berlin, Norway, Oslo. Ooh, okay. So let's continue. So dictionary manipulations. Let's see how to manipulate dictionary one more time. So the last challenge. Somebody thought it would be funny to mess with you with your accurately generated dictionary. So an adapted version of the Eagle dictionary is available in the scripts. So we have adapted it. So can you clean up? Do not do this by adapting the definition of Europe, but by adding Python commands to the script to update and remove the key pair values. Update the capital of Germany. Let's update the capital of Germany. So I'm going to say Europe dot Germany. What is the capital of Germany? Someone is messing with us there. It's Berlin. Capital of Germany is Berlin. As is Spain, Madrid, France, Paris, Germany, Bonn, instead of Berlin, Norway, Oslo, Italy, Rome, Poland, Warsaw, Australia, Vienna. So let's update the capital of Germany. I'm going to say Europe, then open bracket, Germany. Germany should supposed to be in a curly bracket, not curly bracket, rather in a square bracket. Germany, Germany, which is now going to be equals to Berlin. You have to make sure. Am I putting Berlin also? Okay, let me put it in single quote there. Remove Australia. To remove Australia, we're going to use delete to remove Australia. Okay. Then open a bracket. I'm going to colon Europe. So, but we want to in Europe, we want to delete Australia. Australia. Aus Australia. So now let's print out Europe and see what we have here. Print Europe. Let's see if we are on track. Oh, interesting. So we've corrected the capital of Germany to be Berlin. We've actually removed Australia, which is the last you can see. It is not there. Let me move to the left. You can see the last. Let me just switch up my camera real quick there. You can see we've removed Australia. So let's give it a shot in interpreter notebook in Python. Can see. So we've defined, let me just copy this. I'll just purposely cut this out. So we define a new dictionary. We're going to run that, which is correct. Then update capital of Germany. Let's see. You can see now. This is our new dictionary now. Pretty straightforward there. Let's submit our code and see. Interesting. Great job. That's much better. Interesting. So finally, dictionaryception. What kind of word is that? Let's finish this final challenge, but we stop here for all about dictionary. We've covered an important aspect of dictionary. Then we'll move to pandas or tomorrow on day 9. So remember list. There should contain anything. There could contain anything, even other lists. Well, for dictionaries, the same holds. So dictionary can contain key value pairs where the values are again dictionaries. That's interesting. Ooh. So as an example, have a look at the script whether another version of Europe, where another version of Europe, the dictionary you've been working with all along is coded. The keys are still the country names, but the values are dictionaries that contain more information than just the capital. Interesting. So the keys are still the company name. Then the other keys or other dictionary, which is the value. So the value, which is also a dictionary, contain more information like capital is Madrid, the population is this. So, okay, for example, so it is perfectly possible to change square bracket to set elements. So to fetch the population for Spain from Europe, for example, you need Europe, Spain, population. Ooh. So now we are going deeper with the indexes. So use change square brackets to select and print out the capital of France. Print out the capital of France. I'm going to mention the dictionary name first, which is Europe. Europe, then brackets, the capital of France. Use chain square bracket to select the printout, to select and print out the capital of France. Then I'm going to point to France, which is the key value, France, France, move over to with another square bracket. Then want the capital of France. I'm going to point to capital this time around. Capital. So the mistake here, I'll have to put it in quotes here. Single quotes, capital of France. So we can have dictionaries in dictionaries. Interesting. Create subdictionary data. Create subdictionary data. Let's start to do that. Create a dictionary named data. Okay. We want to create a dictionary named data. This is going to be equals to. Let me open curly brackets. Okay. Create a dictionary named data with the keys capital and population. Set them to Rome and 59.83 respectively. So the key is going to be capital, okay, capital in quotes. So I'm going to use this to and population, set them to. So I'm going to mention the capital is going to be Rome. Okay, capital will be set to Rome. Rome. Then again, this is going to have so this dictionary. I'm going to create another dictionary inside it. Okay, let me see. So I'm trying to see the way this was created. Hmm. Now I'm going to use a comma. So now it's going to be population, curly brackets, population. The population is going to be 59.83, 59.83. Let's see if we nailed it. Now we're going to add the data to Europe under the key Italy. So how do we do that? So add a new key value pair to Europe. The key is Italy and the value is data. The dictionary is just built. Oh, so this is our capital, Abi. So you can see the capital from here. That means we got it right. Capital is just like this. Capital is Oslo, comma. Then population is this. But there's a space here. Do I need to create a space here? Let's create a space here. So it's a add data to Europe under key Italy. So I'm going to say add a new key value pair. So how do we do that? To add a new key. So I'm going to say Europe, open brackets. I want to add Italy. So the value for Italy, I will now point to, but sometimes you have to use single quotes, sometimes you have to use double quotes. One need to figure out when to do that. I need to figure out when to use single quote and double quotes. This is now going to be equal to data. Oh, okay, let's see. So I'm going to point Italy, Europe, Italy to data. This data here, this is a sub-dictionary. And let's print out Europe now and see. Let's see. Ooh, we nailed it. I think we nailed it. Let me switch off my camera there real quick. So if you look at our dictionary, you can see the Spain, the capital of Spain, the population of Spain. Let me just move to the last part here. The capital of Italy is Rome, but mine is now in bracket, one more bracket. Is that correct? This Spain, curly brackets, capital in curly brackets. Why is mine now in Italy? Brackets. Why is it giving it extra brackets here? Why? There's supposed to be a curly bracket. That is extra bracket. I actually make use of a curly bracket too. But let me submit it first and see if I'm correct. Oh, you can see I'm wrong somewhere. Did you correctly define the variable data expected? Capital Rome. Let me see. Data should be capital Rome. Population. Correct. But got, why am I getting these brackets? Why? Why? Let me just copy this. Because I got the correct result. Capital. Oh, probably because there's no space. I didn't leave a space here. Let's leave a space there. Let's leave a space here. Let's run the code again and see now. I'm still getting these extra brackets in my results here. Why? Why? Okay, well let's look at it. Well, let me copy this first. Let me listen to the instruction, the help first, and see what is wrong. So my data capital, there's supposed to be a space here. There's supposed to be a space at the end there. That's quite interesting. Europe, Italy. Oh. This time around, they are using a single bracket here. I'm using double quotes here. Why? I need to understand why sometimes you have to use a double quote, sometimes you have to use a single quote. Is that when you're trying to work with them, you use a single quote. When you're trying to manipulate them, you use a single quote. When you're trying to add the record, you use a single quote. Okay, when you're trying to manipulate them, you use a double quote. When you're trying to add the record, you use a single quote. I think I figured that out. Okay, let's see by the way though. Let me know run the code one more time. If I'm getting the correct results. I'm still getting extra brackets here. Why? Why? You can see print out capital of France, Europe. Okay, I didn't use print here. I'm supposed to use print here. Print out the capital of France. Print out. Create a subdictionary. Data equals to curly brackets, capital, column. Okay, let me get rid of these spaces here. There's supposed to be a space here. Oh. Capital Rome, comma, population. Oh, I'm supposed to add in another bracket. So this is another subdivision dictionary here. Oh. I think I've seen my mistake now. My mistake is, in this case, I was adding extra curly brackets here. Even from here, from the capital population, there's no curly bracket, extra curly bracket there. Okay, I've seen my error, my mistake there. Let's run the code one more time. Let's see. You can see Italy, capital, Rome. Okay. So I've corrected my mistake right there. So let's submit and see. Wow, correct. So we got it now. So my mistake was creating in its subdictionary. I was adding extra bracket. I don't need to add extra bracket. I'll just create it like a normal dictionary of key value pair, key value pair, key value pair. Okay. I hope that makes sense. Let me just copy this real quick and make use of it in my Jupyter notebook here. Let's see. So this is a dictionary that we're creating again. I'll just copy this. So this is a dictionary. I'll just run the code. Alright. Then we print out the capital of France, which is Europe, France. The dictionary, France, then the capital. I jump to the capital. It's going to print it out. We created a subdictionary that is normal dictionary, capital, key, pair value, key value, key value. Then we add the data to Europe under Italy. We add a new dictionary, which is Italy, and we pointed to the data that we've created there. So if I print it out, you can see print out the capital of France, which is Paris. Then we added the new data Italy. You can see it here. Where is Italy here? Because Italy, capital is Rome, population is 59 million. Interesting. Wow. So that'll be the end of the live stream. We used exactly 1 hour to learn all about dictionary, from dictionary, what dictionaries are, and motivation for dictionary, creating dictionary, accessing dictionary manipulation, deleting, adding, subdictionary, and all the things we could think of. Interesting. So we spent exactly 1 hour learning all about. All right, so that will be the end of the live stream for today. So if you found value in this learning journey with me, do well to support the channel by giving this live stream a thumbs up, subscribe to the channel, and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. As usual, do well to access the files. This dictionary, so there's not any files for this part, so you could just follow along and try to create your own dictionary following the prompt, the values, key pair values we've learned all about. Do well to access previous live stream on the live stream tab on the channel, and I've also dropped the link under the YouTube description under each video so you can catch up on previous lesson, so you can follow me all the way till day 100. All right, I will see you on day 9, which is